So with this next one, we recognize how we kind of got off easy with that last problem. So the one thing that's changed is we've raised the power of cosine and cosine squared. This puts us in a situation where we can't use substitution method yet because there's no way we could pick a u that would take care of the rest of the integrand with its du. So this is very similar to most of the types of problems that we're going to be running into here. So since u substitution doesn't work yet, here's what we're going to start is we're going to borrow a power from that sine to the power of 5. And we'll see why that is, and we'll generalize how we came to choose that in a minute. But for right now, just kind of indulge me, and we're going to say let's borrow a power. And when I say borrow a power of sine, essentially we're just peeling off one of those factors of sine of x, and we're going to pair it with the dx. So to pair with dx. All right, so let's see what this would look like if we tried to do that. All right, so we've got the integral of sine to the power of 4x times sine of x. So I've peeled off one of those factors of sine, and then we've got cosine squared dx. And I'm going to now write this as the integral of sine to the power of 4 of x cosine squared of x, and I'm going to bring that sine with our dx. Now the reason that we did this is what we're doing is we're setting ourselves up to note that this is going to be our future du. Because the goal here is going to be substitution, that's going to end up having to be our du. So that might give you an idea of what we're going to have to choose as our u in just a minute. So if this is going to be our du, then our u would have to be cosine, right? That would, if we took the derivative of cosine, that would get us to sine of x dx eventually. So how are we going to get rid of this sine to the power of 4? Because we're going to need to make this cosines. All right, and this is going to be our future du. Well, here's where those trig identities come in again. So I'm going to start by, we don't have anything for the power of 4, so I'm going to start by taking that sine to the power of 4 and rewriting it as sine squared x squared cosine squared x sine of x dx. So what we're in the throes of doing right now is we are rewriting the remaining sines as cosines. Now that we've rewritten sine to the 4th as sine squared squared, it might be a little bit easier for us to see how we're going to get that into cosines. We can use the Pythagorean identity to write this as 1 minus cosine squared x squared times cosine squared x sine of x dx. So notice what we can do now. We can go in and we can let u be cosine, and that's going to wipe out all of the x's, and we're going to get everything in terms of u and du. So let's go ahead and do that now. So right here, we already kind of knew that our du is going to have to be sine of x dx, and now letting u be cosine is going to get us there. So our du is going to be negative sine of x dx. We'll multiply both sides by -1, and we'll get negative du is equal to sine of x dx. And now we're going to do our substitution. So we've got 1 minus u squared squared times u squared du, and we put the negative out in front that came along with that du. Now we just need to multiply all this stuff out, and lots of times this might be something we have to do depending on the order of these powers. We might have to do some multiplying and cleaning up, and that's what we're going to do here. So if we multiply this all out, we're going to have negative integral. So if we have 1 minus u squared times 1 minus u squared, that's going to give us 1 minus 2u squared plus u to the power of 4. We still have that u squared out on the outside, out there waiting to come in. So if we distribute that, we're going to have u squared minus 2u to the 4th plus u to the 6th du. Now we've reached a point where we can integrate these term by term and then plug back in what our original u was. So let's go ahead and do that. So if we integrate our u's, we're going to have, what, 1/3 u cubed minus, if we add 1 and divide, we're going to get 2/5 u to the power of 5, and then plus 1/7 u to the power of 7 plus c. And if we distribute that negative and we replace our u's with cosines, our final answer is going to be negative 1/3 cosine cubed x plus 2/5 cosine to the power of 5 of x plus, minus 1/7 cosine to the power of 7x, and then plus c. And that gives us our final answer here. So there was a lot in this problem that we should take note of. A lot of these maneuvers are gonna repeat themselves throughout these examples. This idea of looking at the powers, borrowing one of the factors of one of the trig functions to pair with dx, using those trig identities, and then multiplying out to make it something that we can do u sub with and integrate it. Now, there's one tip that I can give you here. So I would mention that when you have powers of sines and cosines, if there is, so this tip will be summarized a little bit later on down, but if for sines and cosines, if you have an odd power, so if one of the powers is odd, borrow from that function. In this case, sine had the odd power, and that's why I had that initial instinct to pull that sine off of that one. The point being is that we're going to then be left with even powers, which will allow us to then exploit the Pythagorean identities.